Okay, so here we go. This is kind of a graph where you have to mark the coordinates of the maximum, the minimum, and the inflection point. Max and mins come from the first derivative, inflection points from the second derivative. So the first thing that I have to do is I have to find the first derivative. The first derivative is 6x squared minus 6x minus 12. I need to find the critical numbers. This is where 6x squared minus 6x minus 12 equals 0. Greatest common factor of 6 makes life easy. This is where x squared minus x minus 2 equals 0. Now 6 is just a constant. It's never 0. Oftentimes you either ignore it, or, and because it is always positive, or you divide it out, one of the two. But we'll kind of leave it here. If it's negative, I have to take that into account, by the way. So it's not, so 6 is never 0. So this says that x minus 2, x plus 1 equals 0. My critical numbers are x equal 2, x equal negative 1. Now those would be, perhaps, they're both multiplicity 1. So there's a change. That means that one of them is a maximum, one of them is a minimum, because there's going to be a change. Increasing is going to move to decreasing, and decreasing is going to move to increase. So there's going to be a change across that. So one's a max, one's a min. Don't know which one. Well, I can tell which one. This has to be negative 1 because it's to the left of 2. And that's going to have to be 2 if I look at my picture. If I didn't have my picture, right, then I have to depend upon the number line. Then you go to the number line. Negative 1, 2. You know me, I only pull 1 point after we did multiplicity. And for me, that's x equals 0 as my test. He's available. So then I look at 6 times 0 squared minus 0 minus 2. Well, that's a negative number. Well, that can't be right. Yes, that's right. Negative, change positive, change positive. Wasn't paying attention. So remember, you could pull a test point from each interval if you wanted to, and not do the change thing. Now that tells me that what I have is increasing followed by decreasing. Negative 1 is a max. Decreasing followed by increasing. 2 is a min. So I now know that the coordinate point here is negative 1 something, and the coordinate point here is 2 something. Now to find that something, I have to go back to the original function. If x equals negative 1, I want f of negative 1, which is 2 times negative 1 cubed minus 3 times negative 1 squared minus 12 times negative 1 plus 8, which is 2 times negative 1 minus 3 times 1 plus 12 plus 8, which is negative 2, negative 3, plus 20, which is going to be a positive 15. So I now know what the y value is for negative 1. So I have a maximum at negative 1, 15. Now I do the same thing for f of 2, which is 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 plus 8, which might be just as easy using my calculator, which is 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 plus 8, negative 12. So my minimum is going to be at 2, negative 12. So this is negative 12 on my graph. Then I'm going to be looking at the inflection point. So first derivative, this is max min. Then inflection, that's f double prime. Well, f double prime is the derivative of f prime. The derivative of f prime is 12x minus 6. That's easy enough. And set that equal to 0 to get my critical numbers. So 12x minus 6 equals 0. 12x equals 6. X equals 6 divided by 12, or 1 divided by 2. Now that's multiplicity 1. There will be a change across 1/2 that says it is the inflection point. If you're dealing with multiplicity 1s or multiplicity odds, they are what they are, because there's a change across that 0. So the inflection point is at 1/2 something, and now you'll have to do f of 1/2. And so I'll cheat on that. I'm going to come back up here and pull that down. And second insert 0.5. Delete. Delete. Point. Second insert 5. .5, and that's a what, plus 8. That's easy enough, so I don't have to do powers. And that comes out to be 1.5. So the inflection point is at 1/2, which is between negative 1 and 2, so that makes sense. 1.5.